Okay, so let's do this one. Okay, this is example 19. Check that. Yeah, example 19. Okay, I've just left out the limits for the time being because this is a really important integral that you need to take a note of. Okay, I mentioned it earlier in one of the previous examples, but the integral of natural log of x dx, because it's a really important result. I'd like you to focus on this first and we'll worry about the limits afterwards, okay? Now, this would normally be a starter in class, so I'll ask you to pause the video and have a think about it, but don't leave it on pause for too long because you possibly won't get very far. Okay, right, so let's have a look at this, okay? How are you supposed to do that using the by-parts method? Because the by-parts method you need a product of two terms, don't you? Okay. Well, I'll tell you what you do. You just rewrite it slightly, okay? You write it like this, okay? You write it as 1 multiplied by natural log of x dx. Okay, now you've got the product of two terms. You need the product of two terms to use the by-parts method, okay? So I might actually get some space to do it here. Let's see if I can do it. So u, okay, what are you going to let that be? Okay, well, I'm hoping it's obvious. You let it be natural log of x, okay? And dv dx is going to be equal to 1. Some of you might be thinking, I'm not sure why that's got to be obvious. Well, I suppose you do it the other way around. Suppose you had dv dx is natural log x. Can you see? To work out v, you have to do the integral of natural log of x, which is the actual question. Okay, so that doesn't really make sense, does it? Okay. So, yeah, that's why it's obviously got to be that way around. Right? So, du dx then will be 1 over x, and v is going to be equal to x. And then let's see what happens. So the integral becomes uv, which is x, natural log x, subtract integral of v du dx, which is x times 1 over x, which is 1 dx. Okay? And then that is just x, natural log x, subtract x, and then plus c. So a very important result. Okay, the integral of natural log x is going to be x, natural log x, subtract x. Okay, and that is it. As a result, you can memorise if you want, because sometimes in an exam you need to use that as part of a larger question, and if you want you can just quote it. That's fine. If you don't remember, you've got to remember this method for actually doing it. Okay, but natural log of x, it's a good chance it comes up in every single exam. Okay. Now what I'm going to do is I'm going to go through actual example 19 with the limits. Okay, I'm just going to check what limits they use. They use 1 and 2. So just put them in there. 1, 2. How does it change things? Okay. Well, this is the first time I've gone over a limits question using by parts, isn't it? So I'm going to just talk you through how that works. Okay. Now this here, and our first real bit of working to discover what the integral is, we've got this. Okay, which is part of our final answer. The limits need to be substituted in there. And so that's 1 and 2. And then we've got to subtract this integral. And when we've integrated that, the limits need to be put back in. So in this line, notice how I put the limits on the integral sign itself and on the final bit that's we've actually integrated. And then here on the final line, if you want, you can just cover all of that. Limits between 1 and 2. And of course, with limits, there's no plus c. It looks messy, doesn't it? There we go. Nice and clean. Monica clean. No, nothing's Monica clean, is it? Then we just substitute them in. So 2. So we got 2 natural log 2 subtract 2. Okay, so that's putting 2 into it, and then we'll put 1 into it. So subtract, let's put it in brackets, x natural log 1. I'm going to write it in anyway. So 1 times by natural log of 1, subtract 1. Let's expand brackets. 2 natural log 2, subtract 2. Natural log 1, of course, is 0. Okay, and subtract negative 1, the same as plus 1. And so we end up with 2 natural log 2, subtract 1. And that is it. Okay. I'm just checking it's our final example. Yes, it is. Okay, that's it. All right. Okay. Well, before I leave you, okay, But halfway through doing this, I was thinking it's a bit like Big Bang Theory, isn't it? You know, because they sometimes are in their living room or their garage or whatever, and they've got a board and they're working through some interesting stuff. Okay. You might be wondering about Lord Vader, Darth Vader. Okay. Well, he follows me. Okay, he follows me everywhere. Okay, it's not just because I like Darth Vader either. Okay, Darth Vader is particularly special to me. Okay, because it was a gift. Okay? It was a gift, and you can see on the reverse. There we go. Yeah, my special messages that I've had. Okay, so hopefully you can just sort of see that. Okay, it's kind of nice. Okay, so yeah, a few people that I used to know, and yeah. It's always nice. Okay, so it's 2008. A long time ago, isn't it? In a galaxy far, far away. Yeah. Yeah. So yeah. So Matthew, Russell, Alex. Yeah. Great. Yeah. Good bunch of people. So they came from one of my Year 13 classes. Okay, and obviously they loved the maths as well. Okay. Yeah, it's kind of nice. Yeah. Matthew's actually just finished Cambridge University. He's got a PhD now. Clever Matthew. Anyway, that's by parts. Okay. I hope you enjoyed it. Okay. Along with substitution, it is really important method. Okay. Really important method of integration, and it helps us to integrate a lot of these difficult things. Okay. Now, if I just do a quick walkthrough with you with exercise 11F, because that's the exercise you're going to be doing. Okay. They're all pretty good questions, but focus on 1 to 4. All right, 5, 6, 7 are when you've done 1 to 4 and you're wanting to just have a bit more practice. Okay, but focus on questions 1 to 4. I normally set the ACEs for classwork and the other ones, the BD, F, no, BD, yeah, F and so on for homeworks. Okay, only question 4 of those has got limits, so it's a good idea you practice some of those. Okay. But what I would say is just, yeah, try and just work through as many of them as you can. Okay, there's some interesting ones in there. So, for example, C with the x sec squared x. Okay, E with the x over sine squared x. You might have to think about what to do with that. Question 2, part D with the natural log x all squared. Yeah, interesting. Okay, and I missed it. Part C on question 2, natural log of x over x cubed. Yeah. Okay. Yeah, they're kind of nice, but all of these, notice they're all a product of 2 terms, aren't they? One is always algebraic, okay, and the other one is often exponential or trigonometric or natural logarithmic. Okay, I mean there are exceptions, yes. I mean like question 3C, all of that is algebraic. Yeah, but yeah, you can still use by parts on it. Okay, well I hope you enjoy exercise 11F. Okay. And feel free to let me know how you get on. See you. May the force be with you.